Now we shall import the mesh for impeller and diffuser. Scroll down in component systems, drag and drop mesh here. Right click mesh and then import the mesh file. First let us import the mesh file of impeller. Impeller mesh file is given in .cfx format. We can use this format for importing the mesh. We shall rename this as impeller. Now again we shall drag and drop this mesh tool. Now we can import the mesh file of diffuser. Import mesh file. Drag and drop mesh to the setup. Similarly for impeller and diffuser. Now right click setup and click edit. Now CFX preprocessor will open. Now all the three mesh files are imported into CFX. Now the mesh files are in different orientation. We shall try to align the impeller and diffuser together. We can see the mesh file of volute, impeller and diffuser imported here. Right click impeller and choose transform mesh. In the transformation choose rotation and specify the axis of rotation and rotation angle. We shall change the rotation by roughly 45 degrees and click preview. We shall change it further to 90 degrees. We shall shift the diffuser to the left of this, so we can keep the impeller at 70 degree angle. Click apply. We can rotate the diffuser by minus 20 degrees. Now the impeller and diffuser are aligned very well. Click apply. Even if the impeller and diffuser are at different angular orientation, the analysis will complete and then there will be no change in the results. However, for post processing and viewing the results together, we need to have impeller and diffuser aligned in same position. We shall change the machine type to centrifugal compressor. Now the rotation direction is pointing in the right direction with respect to this impeller. So click next. By default it has chosen R1 as all the components. So here you have to go to available volumes and in the drop down menu we can choose the particular passage, impeller passage, or you can click these three dots and then choose the passage from this selection dialog. Now R1 mesh is chosen. We shall change the RPM value. It is 35,000 for this particular case. It has automatically chosen the passages as well as region information. Now we have to specify the tip clearance at shroud. Yes. Next we shall define the diffuser as well as volute. The second component is stationary, that is S1, and from the available volumes we can choose the diffuser mesh. Passage is for impeller, passage 2 is for diffuser. Click OK. It has chosen the regions. You can right click component and then choose add component, choose stationary S2. S2 will be volute. So from the available volumes we can choose volute mesh. Click OK. Here, since it is not a typical turbo machinery component, here the region information will not be available. It will be shown as unmatched regions. We shall edit this in the general mode. As of now, we can click next and then proceed for applying the boundary conditions. We can choose air as ideal gas, reference pressure is 0 atmosphere, total energy. We shall choose total inlet pressure and static outlet. We can also choose total inlet and mass flow outlet, but this may not be advisable when the flow is choked. So where the mass flow will be constant, however pressure will be varying. So it is advisable to choose total inlet and static outlet condition. But in certain cases, we have to choose total inlet and mass flow outlet. That will be near the stall region or surge region, where the mass flow variation will be more than the static pressure variation. Now for this case, we shall choose total inlet pressure and static outlet. Inlet total pressure will be 1 bar. Total temperature will be 15 degrees Celsius. The flow direction is normal to the inflow. We can specify the swirl angle also based on these options. For example, we can choose Cartesian components and then we can specify the axial, radial and theta component. However, the square root of sum of the squares of each component should be equal to 1. As of now, we shall choose normal to boundary. The static pressure at the outlet is 3 bar. Let the interface be default stage interface. Click next. R1 to R1 periodic interface, S1 to R1 stage interface and S1 to S1 periodic interface. We shall specify the S1 to S2 interface in the general mode. Click next, next, finish. it is showing a warning related to turbo report generation. Click yes. Now we have gone to the general mode. Here we can see R1 and S1 has got well defined regions, but S2 is having no boundaries defined. It is only having S2 default region. Please note that whenever you complete the case, there should not be any region with the name default. If it is default, it means the boundary condition has not been assigned by the user and CFX has chosen the default interface. By default, this interface will be having wall boundary condition. So we have to choose this boundary properly. First we shall specify the interface for diffuser to volute. Right click interface and then choose domain interface S1 to S2. Click OK. Here in the filter you can choose S1 for the first side and S2 for the second side. In the regions you can choose outflow for the first side, that is diffuser, and volute inlet for the volute side. You can choose stage interface for this case. Click apply. Here it is throwing a warning that S1 outlet is already being used for another boundary surface. By default it might have chosen S1 outlet as the overall outlet for this particular domain. Now we shall change it. Click OK. We shall right click and delete S1 outlet. Now still there is one S2 default. We have to specify the S2 outlet. Right click S2 and choose the boundary. S2 outlet. We shall choose outlet, location, volute outlet, boundary details, average static pressure. We shall specify 3 bar. Click OK. Still there is one S2 default. We shall right click S2, insert boundary, S2 casing. This will be a wall boundary. We shall choose the volute casing. Click OK. OK. There is a error message here. The parameter outflow boundary in flow analysis holds the following disallowed value S1 outlet. Allowed values are S2 outlet. Sometimes we can double click this and then click OK. The error message will vanish. Now the case is set up. We have to specify the expressions for monitoring the pressure ratio, temperature ratio, efficiency and mass flow rates. Let me quickly specify the expressions. I have to check the number of blades for R1. (12 blades). Click apply. S2 outlet into -1. Apply. Here the expressions and output control are given. We shall change the solver control settings. Now we shall solve the case in CFX solver.